essay quiz number 2. The problem that's given is 4 minus x minus 3x to the 4th. Find the points of inflection and discuss concavities. Basically the instructions. Well, since this is the essay question, I'm going to give one that's similar to that, which is 2 minus 7x to the 4th for f of x. F of x equal to 2 minus 7x to the 4th. Okay, so to start with, this is a lesson, this is out of lesson 3.4 in your textbook. And so you need to use the second derivative test to test for concavity. And so let's take a look at that real quick from the textbook. So here's our textbook. I'll zoom in on that. To find the second derivative test, let f be a function such that the derivative f of c equals 0. So at some critical point, we find the critical point by setting the first derivative, and then the second derivative. First we have to find the first derivative equal to 0, and then a second derivative f exists on an open interval containing c, so that the second derivative, if it's at some critical point, is greater than 0, has a relative minimum, and if it's less than 0, has a relative maximum. So this would, if it's greater than 0, then it's going to be concave up, and that would give you a relative minimum. It would concave up, so you get a minimum. And so if the second derivative is negative, then it's concave down, and so you get a relative maximum. Now this is the point that I want to emphasize here. If the second derivative equals to 0, then the second derivative test fails, and there's no relative maximum or minimum, and so there's no the second derivative test fails, which means there's no so we have to use a different means. So that's why I wanted to come up with this video to show what do we do if the test fails. Alright, and so how can we find concavity from that point? Alright, so the first thing we're going to do is find the first derivative to this function. So first derivative is going to be, the 2 will go to 0 minus 7, and then the 4 comes down, right? 7 times 4 x, and then we subtract 1, and so we get here negative 7 times 4, that's going to be 28 x to the 3rd is our first derivative. And so the second derivative is going to, so again we're going to bring that 3 down, so it'll be negative 28 times 3 x, and then we subtract 1 from that and get x squared. And so our second derivative, negative 28 excuse me, negative 28 times 84 is a negative 84. Negative 28 times 3 is a negative 84 x squared. So if we were to find the point of inflection, we'd have to set that equal to 0, negative 84 x squared, and then we divide by negative 84, divide by negative 84, we get 0. 0 divided by anything is still 0. And then apply the square root to both sides, and we get x equal to 0. Well, there's 0 doesn't have a positive or negative, it's just 0. And so we drop the plus or minus. So since our second derivative equals to 0, it fails the second derivative test, so there's no point of inflection. So we have to revert to the first derivative test to find that. So we go to the first derivative, right, which is negative 28 x to the third. Okay, our first derivative was negative 28 x to the third. So we put in our first derivative. Here's our first derivative again, negative 28 x to the third. Set it equal to 0 and solve. So it's negative 28 x cubed, and again we divide by negative 28, divide by negative 28, and we get 0 equals 2x cubed, and then we apply the cube root. Well, the cube root of 0 is going to be 0. So that's our critical point. So that means that we're going to look at our table. So we're looking at negative, if we're looking at this as a number line, here's 0, here's negative infinity, here's positive infinity. So we're looking at from negative infinity to 0, since that's our critical point, and 0 to positive infinity. So that's negative infinity to 0, and then 0 to positive infinity. And we need to determine if our derivative, we use a test point. So here's our interval. On our test point. So our test point, since we can use anything, well, negative 1 is easy. So we're going to use negative 1 for test point. And so we put that in our first derivative, and we see, is that going to be greater than or less than 0? So off to the side, we put negative 1 into our first derivative, right, equation, negative 28x cubed, negative 28, and then where x is, we put negative 1 cubed, and we get, let me lower this down so I've got enough room, negative 1, negative 28 times negative 1 cubed. So that's going to be negative 1 cubed, that's still negative 1, so it's negative 28 times negative 1. We get a positive 28 out. So that'll be 28, which is positive, that's greater than 0. So this interval is increasing. So we're applying the first derivative test to determine if it's concave up or concave down. So now we put in, now we need another test point. So here we can use +1. That's an easy number to use also. So we looked at the interval from -infinity to 0, and we used -1. Now we're looking at the interval from 0 to infinity, so we're going to apply a test point of +1. So we put +1 in there, and so we put in +1, and so there'll be -28 times +1 cubed. Well, +1 cubed, that's still just +1, so that's -28 times +1, and that gives us a -28. So f prime +1 equals 228, which is no, -28. -28. And so that's less than 0, and so that is decreasing. So our curve was increasing on the interval from -infinity to 1, and then decreasing from -infinity to 0, and then decreasing from 0 to +infinity. So since it was increasing and then decreasing, we can say f is increasing from the interval -infinity to 0, and decreasing on the interval from 0 to infinity. Therefore, I'm writing it in terms of how you would write it in the essay. Therefore, the f is, our function f is concave down. And so you would write the essay from there, and that's how you would do the essay question exactly, pretty much exactly, almost exactly the same way. The only thing that's going to be different is instead of 0 here for your critical point, you're going to have like this, like cube root of something, 1 over some number, and I'm not going to do that. I want you to find that. Okay, so that should help, and let me know if you have any other questions, and have a great day.